This is the Anglian transverter by G4DDK. In this video I am going to look at the reciprocal mixing on the receive side. To do that I have here a good crystal oscillator on 48 MHz, and after that a frequency tripler. And that is followed by this box, which contains some 70 ohm cable and makes a hybrid that splits the signal into two. And each signal goes into an attenuator, and one of the attenuator goes into the Anglian, the other one goes into WSE converter, which I can't see from here. The Anglian transverter goes into this box, which is a Perseus SDR. This is the screen of the Perseus. I have set the S meter to show 0 for the carrier. 0 dBm. Well, that's not what it is, but that is a reference, 0. And I step 5 kHz away from here by clicking 5 kHz below the signal. And sorry, I have to remember where is the signal. That is 048, so I want 043. That's here. The bandwidth is 1 kHz, and 5 kHz away the noise floor I can see is like that, 99.2 dB below the carrier. Uh, 99.2, and then I go 10 kHz below. That should be about here. 38 is what I want, so I click on 38 and then get the noise floor in 1 kHz bandwidth as minus 102 dBm. And then 20 kHz, that would be 28. That's here. And here the noise floor is minus 103.6. And I can switch off the strong signal completely by disconnecting a cable here. And then the noise floor goes down considerably. So the noise I have been seeing is reciprocal mixing. The noise from the box is not high. It is at minus 114. And note that I have had to set the attenuation of the Perseus to minus 20 dB. I can change that, 10, 20 dB, and see that the noise is going up nearly 20 dB, which means that the noise floor I see is the noise floor from the Anglian and not from the Perseus. Here is the screen of the WSE converters, and I do the same here. The carrier is at 0, bandwidth 1 kHz, and I step 5 kHz down. We are at 049 in this scale, so I want to go to 044, 5 kHz. 044. something like this. And here the noise floor is well, I have to wait. Minus 113. That's almost the same as we had with the signal off in the Perseus. And I am doing this just to show that what I see is reciprocal mixing in the Anglian and Perseus combination, and not sideband noise of the test oscillator. And you can see here the noise is flat. And if I switch off the signal, and you can see it is microphonic. Now I disconnected it, and the noise floor does not change. So there is no reciprocal mixing and no phase noise. It's just the dynamic range of the sound card used for the WSE converters that sets the limit here. To make sure that the phase noise I have seen with the Perseus is from the Anglian transverter and not from the Perseus itself, I have arranged a 28 MHz signal by use of this 14 MHz high quality crystal oscillator. I send it into 2 ports of a Schottky barrier mixer. From the 3rd port I will get the sum and the difference. The difference is DC, and I'm not interested in that. The sum is twice the frequency, 28 MHz. The signal level is not high enough, so I have amplified it with this amplifier. And then I send it into the Perseus. And we can see some sideband noise here, which is probably from my oscillator arrangement. But I can evaluate what the level is by clicking 5 kHz away. It is 28,317, so I want 323. Oops, closer. Here. So this is the sideband noise level at 5 kHz. And it's minus 110. So it means that the value I saw with the Anglian at minus 99 was actually due to the Anglian transverter. And if I go to a separation of 10 kHz, that means, what would it be? 28. Something like here. I see a level of minus 112, 13. And I had minus 102 with the Anglian. And 20 kHz away, 338. That's here. And the level is minus 115 compared to minus 103 with the Anglian. So the results were correct. And so here is a summary of the results from this video.